Hey everybody, this is the notes for section 5.1. This chapter is kind of a departure. It's a little bit of a change of pace from what we've been doing. You're gonna go like, oh, this. And then in chapter 6, we sort of come back around. So take the breather that you get here a little bit. It's not gonna be super easy necessarily, but it's just different. And sometimes different is okay. So in here, in 5.1, we're gonna multiply and divide expressions with common bases. What we're really talking about this in this chapter is integers. So this really should be b to the n. So let b represent any real number and n is a positive integer. If I have b to the n to the power of n, it means I have that many b's. I have n factors of b. So if you think of it this way, if I have 2 to the 4th, what I really have is 4 2's, right? Times 2 times 2 times 2 times 2. For each expression here, we're going to identify the exponent and the base and then evaluate. Remember that you have a calculator that you're allowed to use, so the expectation is that you will. So the base is 6, the exponent is 2, 6 squared is 36. In your calculator, what you're going to do is you're going to push the 6. There is a caret key. That's what makes an exponent, and then the 2. Okay, that's going to get you 36. 1/2 here, -1/2 is the base. The exponent is 3. In your calculator, you're going to do it just like it looks like, half in parentheses, then the caret key, then the 3. Half cubed is just half times half times half. That's 1/8. And then think about negative times negative is positive times another negative is negative. Okay? And then this one is 0.8 to the 4th. 0.8 is the base. 4 is the exponent. That's going to equal 0.4096. I think you get the idea here. What we want to try here is something a little different. This looks the same, but it's not. So just sort of bear in mind where this is going. If I have -5 to the power of 4, look at A and B. They are not the same. Okay? Here in A, the implication without the parentheses is that this is what's happening. Because the negative is technically a -1 and exponents come before multiplication in order of operations. So really, it's the negative on 5 to the 4th. So what the answer to this one would actually be is -625 because I would do the exponent, then the negative. However, in B, it's different. It's -5 to the 4th power, and that is going to be just regular 625. Okay? If you need to write it out, do that. Okay? For the next one, they're an odd exponent each, so it's going to be negative. This you're just going to put in your calculator. Okay? -0.08. It's going to be the same here because when the exponent is odd, it doesn't really matter if I'm raising a negative number to a negative, or raising a negative exponent. Oh my goodness. Raising a negative number to an odd exponent, the answer is going to be negative. We don't need to do these, but you get the idea that this one should be -16 and that one is 16. All right, so now we're going to go a step further and evaluate expressions. So what I'm going to do is I'm going to put 2 in where I see A and B where I see B, I'm going to put -3. So 5 times A squared, I'm going to put the 2 in. And remember that the squared is applied first. So it's never 5 times 2. Remember order of operations. Exponents becomes before multiplication. So it's going to be 5 times 2 squared, which is 4. That's going to be 20. The answer changes, right? If the order changes, and the way we change order in math is we use parentheses. So in this case, I have 5 times 2. That's all in parentheses, then squared. So 5 times 2 is 10. 10 squared is 100. And you can see based on the order that you do things, the answer is really different, right? For C, I'm going to do 5 times 2 times -3 squared. That's what B is. Okay, so -3 squared is 9 times 2 times 5. I'm just going to write it like that. 5 times 2 is 10 times 9 is 90. And then for the last one, be really careful. So what I'm going to do is I'm going to put in the b, the -3, plus the 2, that squared. I'm going to do the math inside the parentheses first. In order of operations, parentheses always come first. So -3 plus 2 is -1. -1 squared is 1. All right, now some rules. If I have b is a real number and m and n are positive integers, then if I have b to the m times b to the n, it's the same as b to the m plus n. What that really means is if I have 2 to the 4th, no, it doesn't look like a 4 now, does it? Times 2 to the 3rd, what I really have is 2 times 2 times 2 times 2, and then times 3 more 2's. It's really just 2 to the 7th. So I'm really just adding the exponents. Okay, in a division situation, if I have b to the m over b to the n, I'm going to subtract. Here's how that would look. So if I had 2 to the 5th over 2 to the 2nd, oh my goodness, nothing is writing correctly today. Fingers must be cold on my screen. Really what that means is I have 5 2's on top, and I have 2 2's on the bottom. When I have same number on the top and the bottom, they make a 1. So what I can do is I can cancel those guys, and what I have left over is 2 to the 3rd, which is the same as 5 minus 2. All right, so let's put that into practice. You try these. For the first one, you should get w to the 7th, right? And the second one, it should be 2 to the 7th. But when you can, you should, if you have a number to an exponent, you have a calculator. Like w to the 7th is simplified. 2 to the 7th is not. You can put 2 to the power of 7 in your calculator and find out that the answer is 128. So the answer should be 128. All right, so what happens here? T to the 6th over t to the 4th. If you need to write these out, it is okay to visualize what you're doing and write it out. Never feel bad about making it clear in your own mind. Okay, 6 over 4. So these guys disappear. That leaves me with t to the 2nd, 6 minus 4. The same thing is going to happen here with the 5's. It's going to leave me with 5 squared, but I'm not going to leave that like that. That's bad math manners. I'm going to rewrite it as 5 squared, which is 25. All right, now they get a little more complicated. I'm always going to combine, simplify where I can first easily. So if I have addition to do, I'm going to do that. So for A, I'm going to do, on the top, I have z to the 9th over z to the 3rd. 4 and 5 is 9. And then 9 minus 3 gets me z to the 6th. All right, for B, I'm going to combine the bottom first. So I have 10 to the 7th. 10 with just nothing there is just one of them. 10 to the 7th over 10 to the 3rd. It's going to get me 10 to the 4th, and I'm not going to leave that like that. That's bad manners. So that is going to be 10. 1 was 4 zeros, 10,000. All right, for C, I'm going to get A on the top, A 9, 10, 11, A to the 11th over A to the 7th. Subtract those, that's going to get me A to the 4th. And then on the bottom one, I have 5 to the 9th on top, 5 to the 7th on the bottom, 5 plus 2. And then if I subtract, I get 5 squared, which is the same thing as 25. Okay? All right. We are going to use the commutative and associative properties to simplify these expressions. So what we're going to do is we're going to combine each kind of thing together. Okay? So I'm going to do them in colors. So first, I'm going to like match number to number. Number to number. 2 times -3 is -6. Then I have the p's on both sides. So I have p to squared times regular p. That means I have 3 of them. I have p to the 3rd. And then I have q's. I have q to the 4th and q to the 5th. That makes q 4, 5, 6, 7, 8, 9. Q to the 9th. That now is simplified. That is it. Okay, so let's try B. I'm going to do numbers first. 16 divided by 4 is just 4. All right. Then I'm going to look at the W's. W to the 9th over W to the 8th. There's one W left over, just plain W. And then I'm going to deal with the Z's. Z to the 3rd over 1Z means Z to the 3 minus 1 is Z squared. That's all. So you do C and D. Let's see what happens. Pause and try them. Okay. So I'm going to get negative 12 x to the 7th, y to the 10th for C. And for D, I'm going to get 9 x to the 3rd, y to the 4th. If you're stuck, come into discussion. Let's talk about it, okay? There is one other kind of thing here. And so this is an application of exponents. What you need in order to be able to do this is the formula for compound interest. And here it is. This is like the second formula you need to know in this class. The formula for compound interest is this. A equals P 1 plus R to the power of T. So what this means is this is the amount A, P is principal, the amount initially invested. R is going to be the rate as a decimal. And T is the time. So if I use the information I have here, it says find the amount in an account after 8 years if the initial investment, $7,000, and is invested at 2.25% interest. So I want to find the amount. I invested $7,000 at 2.25%, which is 0.025 for 8 years. So now it's just math. So in the parentheses first, right? So I have 7,000 times 1.025 to the 8th. Well, put it in your calculator in order. 1.025 to the 8th times 7,000. What are you going to have after 8 years? You're going to have 8,528.82. That's all. This is how it works. All right, you try the next one. Find the amount in account after 3 years if the initial investment is $4,000 at 5% interest compounded annually. That's all you're doing. The exact same thing we just did. Put it in the formula. When you're done, you should have $4,630.50. If you're stuck, come on into the chat or the discussion. Let's talk about it. I will see you in the next section.